types of questions together on the notes for this section. Now this says two-step equation. Often is two steps. It can be more. So multi-step equation would be more accurate. But this is section 2.3 in Algebra 1. And in the sheet I have in front of me, numbers 1 through 6 are all the same type of problem. So if you look, they're all in a single line, and there's no division involved. So for all of these, the first step is to add or subtract to get rid of the constant. Now the constant is the number that's by itself, has no variable, but it's also on the variable side. So as I look at the side with the variable, I see a coefficient, -8, and this constant, 4. You could consider it -4 if you wanted to. So for 1 through 6, all of those, your first step is to get rid of the constant. So you add 4 to both sides. Your next step is to get rid of the coefficient, because we want the variable, in this case n, to be by itself. So I divide both sides by -8, and I get n equals 16. So in the questions in this format, single line, no division. Step 1, get rid of the constant. In this case, subtract 1. Then get rid of the coefficient. In this case, divide by -10. Okay, now number 3, our constant on the side of the variable is the 5. This is a positive 5. Yes, there's a minus sign here, but the minus does not apply to the 5. We're subtracting m, not 5. So since this is a positive 5, we subtract 5 from both sides. And that minus becomes a negative sign in front of the m. So this really is a coefficient, because there's an understood 1 in front of here. So there's an understood coefficient of -1 that we have to eliminate by dividing both sides by -1. So I'm going to say it again, probably more than once. When there's just one line and there's no division, the first step is get rid of the constant, which in this one is 9. The second step is to get rid of the coefficient. In this case, we divide by -7. So I'd encourage you to pause and try these two on your own. We take care of the constant, the 6, so we subtract 6 from both sides. Then we take care of the coefficient, which is 3, so we divide both sides by 3. Okay, here the constant is -6. Since the 6 is negative, we have to add 6 to both sides. That minus sign stays with the r as a negative sign. -2 plus 6 is 4. And just like back in number 3, this negative we know really represents a -1 coefficient that we have to eliminate. So we divide both sides by -1 and get r equals, let me try that again, r equals -4. Because positive 4 divided by -1 is -4. Now the next set, I believe it goes from 7 through 12. I'm not going to turn to the back yet, but 7 through 12 all have this form. Notice how they all have a fraction, but the fraction is just a piece of that side. It's not this whole side that's a fraction. It's just a piece. Just one term is a fraction. M over 4. Just one term is a fraction, x over 2. X over 2, p over 5. To make sure you see what I'm trying to differentiate, the last set, which is 15 through 19, the entire side is a fraction. We'll deal with that later. But the set we're dealing with, it's not the entire side of an equation that's a fraction. It's just one term that's a fraction. With these, the first step is to get rid of the constant, then get rid of the denominator. So we'll subtract 10. And then to get rid of the denominator, we multiply both sides by that denominator. We get rid of the constant. Then to get rid of the denominator, we multiply by that denominator. We get rid of the constant. So minus 8, so we add 8 to both sides. Then we get rid of the denominator. We do that by multiplying by the denominator. So again, we recognize the pattern. The pattern is we have a fraction, but it's just one term that's a fraction. When just one term is a fraction, we get rid of the constant first. Then we get rid of the denominator. To get rid of the denominator, we multiply both sides by the denominator. On 11 and 12, we're still dealing with the same type as we did on 7 through 10, where there is division, but it's just in one single term. It's not dividing the whole side like we'll do on the last few, but there is division in one single term. So just like on those, our first step is to get rid of the constant, so we subtract the 8 from both sides. 8 minus 8 is 0, that's why that disappears. 5 minus 8 is negative 3. Then we multiply both sides by 3, because we got to do the opposite. This is being divided by 3. We do the opposite and multiply by 3. Gives us n equals negative 9. We'll do the constant first. Subtract 5 from both sides. 5 minus 5 is 0, so that disappears. 0 minus 5 is negative 5. Then we multiply both sides by 2. 2 times negative 5 is negative 10. The 2's cancel. 2 divided by 2 is 1, so there's just 1 m left. So that's type 2, ones that have division in one single term. The last type is 13 through 19. That's where the entire side, it can be the left or the right side, is being divided by a number. For this type, when you have a whole side being divided by a number, you need to first get rid of the denominator. So in this case, we'd multiply both sides by 2. So the 2's cancel out, because 2 divided by 2 is 1, leaving just b plus 10. And 13 times 2 is 26. And we take care of the constant last, so we subtract 10 and get b equals 16. We see, okay, this is one where the entire side is being divided, so the whole side's a fraction, so we multiply both sides by that denominator. So 9 divided by 9 is 1, so we just get 1 times this, which is itself. 9 times negative 1 is negative 9. Then to get n by itself, we subtract 3 from both sides. Get negative 12 equals n. And you can always check your work if you want. If you plug negative 12 back in for n, 3 plus negative 12 is negative 9. Negative 9 divided by 9 is negative 1. 15, we see an entire side is being divided. So we get rid of that by multiplying both sides by the denominator. They cancel out right here. 5 divided by 5 is 1. 5 times 5 is 25. Then we get rid of the constant. We subtract 6 from both sides and get r equals 19. (16) is also of this type. The entire side is being divided, so we fix that by multiplying both sides by 8. We get x plus 2 equals 16. Oh, sorry, that's not the final answer. It's a correct step, but we're not done. We got to get rid of the constant by subtracting 2 from both sides. 2 minus 2 is 0, so we're just left with x. 16 minus 2 is 14. So that is the correct answer. 14 plus 2 is 16. 16 divided by 8 is 2. 17, multiply both sides by 2. This 2 and this 2 cancel out because they're multiplying by 2 and dividing by 2, so they just cancel out. 2 times 12 is 24. Then we subtract 5 from both sides. So another way you could look at this, when we're saying solve for a variable, our goal is to get the variable by itself. So we first got the variable by itself by getting it out of the fraction. We multiply both sides by 2. Then we had to get rid of the 5 that was tagging along, so we subtracted 5 from both sides. So on 18, we want to get rid of that 20 first, so we get rid of the 20 by multiplying both sides by 20. That cancels that 20 out. Negative 1 times 20 is negative 20. Now that 2 is still in the way, so we need to add 2 to both sides. We get n equals negative 18. And the last one, we have an entire side being divided, so we start by multiplying both sides by the denominator. The 2's cancel out on this side. 2 times negative 4 is negative 8. And we want to get rid of the 5, so this is a positive 5, so we subtract 5 from both sides. Get negative 13 equals n. So make sure you recognize what type it is and what to do in each of those types. So just quickly, sorry to my work showing right now, but if it is one line without any division, you take care of the constant first, add it or subtract it, whichever is needed, then divide to get rid of the coefficient. So constant, then coefficient. This one's very similar. When you have a fraction in just one term, you take care of the constant first, then you'll multiply to get rid of the denominator. So with both type 1 and type 2, we take care of the constant first, then we multiply or divide, whichever is needed, to get the variable by itself. Then in the third kind, which is what the last, I think, 7 we did were, our first step is not the constant. Our first step is to get rid of the denominator because it's covering the whole side. So multiply to get rid of the denominator first, then take care of the constant.